In 1926, in Tordo took Ford just 3.4 days to convert iron ore into a Model T car. In 2006, it took Tata 270 days. Why would a similar end-to-end automated supply chain after 80 years become 80x slower, despite all the technological advances in production and transport? Both Ford and Tata owned most of the links in their supply chain. What can explain the difference? And can answering this mystery also help us solve the question of whether links in a supply chain should be owned by government or the private sector if you want to ensure products, services, and projects is done at the lowest cost, fast enough, and with good enough quality? Welcome to another episode of Deep Dives into Theory of Constraints.
I am so incredibly excited for this one. It's just a wild comparison.
This mystery is at the heart of a fascinating white paper by Dr. Barnard, CEO of Goldratt Research Labs, titled Why Owning the Chain Doesn't Make It Flow.
Yeah, and it's heavy on the data, but honestly, it's one of the most profound industrial mysteries we've ever unpacked here.
Totally. So the goal for our deep dive today is to basically deconstruct this 80-year-old mystery. Mm-hmm. We're going to figure out exactly why common ownership, buying up every single step in your supply chain, why that did not result in smooth flow.
Right. It actually made things worse in some ways.
Yeah. And we're also going to explore this hidden, really vicious mathematical curve that explains why your own simple tasks get endlessly delayed at work.
Oh, the queuing theory stuff? Mm-hmm. Yeah, that part is going to hit home for a lot of people.
Definitely. And ultimately, we will uncover the alignment mechanism that actually works in the real world. So to you listening, whether you're maybe a supply chain executive trying to untangle a global network, or someone frustrated by bureaucratic delays in your community, or just a manager trying to get a project done at work without it stalling for 6 months, this deep dive is going to fundamentally change how you view efficiency.
It really will. It flips the whole concept of efficiency on its head.
So let's look at the physical reality of the data first. Because, to figure out why the modern supply chain was 80 times slower, we have to look at where the time actually went.
Yeah, the physical data is where this mystery really takes shape. So let's look at Henry Ford's River Rouge complex in 1926. Ford's system turned raw iron ore at the mine into a customer-ready car driving off the lot in 81 hours.
Which is it's crazy. That's just over 3.4 days.
Exactly. Then we jump forward 80 years to 2006 and look at Tata, which is, one of the world's great industrial groups. And just like Ford, Tata owned nearly every link in the chain.
Right. They had the whole vertical integration thing going on.
Yeah, they own the iron ore mines, the steelmaking plants, the vehicle assembly factories, and even the dealerships. Yet their end-to-end lead time wasn't 81 hours. It was roughly 6,400 hours.
Wow.
Which is about 270 days.
Okay, so if I'm looking at this data, my immediate reaction is that a 2006 vehicle is just vastly more complex than a 1926 Model T. I mean, a modern car has airbags, microchips, anti-lock brakes, thousands of specialized parts.
Right, of course.
And Ford famously offered exactly one color. So isn't this basically an apples to oranges comparison based purely on modern product complexity?
What's fascinating here is that Dr. Barnard addresses that exact logical objection right up front in the white paper. Product complexity and variety are absolutely real factors.
Right.
But if they were the primary culprits, they would mathematically have to result in longer active production times or, longer transport times.
Okay, that makes sense.
But when we look at the 2006 Tata chain, the amount of time out of those 270 days actually spent building or moving the car was incredibly small. Active production took about 5.5 days.
Wait, really? 5.5 days out of 270?
Yeah. And transport took maybe 10 days?
Oh my God. That leaves a massive gap.
Sure.
We're talking about maybe 15 or 16 days of actual work and movement out of nearly 9 months.
The complexity argument entirely falls apart right there because 94% of those 270 days, so about 252 days, the material was just waiting.
Just sitting there.
Literally just sitting still. It wasn't being transformed by advanced modern technology, and it wasn't moving. The white paper breaks down this waiting time into these staggering chunks. About 103 days were spent waiting as raw material stockpiles before the manufacturing chain even really started.
Wow.
Then another 12 days sitting in work in process queues on the factory floors. And the largest chunk of all, 137 days sitting as finished goods.
So that's just steel resting in stockyards, vehicles parked in vast plant yards, cars sitting on dealer lots.
Exactly. Only 6% of the total time was spent transforming or moving the material.
And compared to Ford in 1926, that ratio is completely inverted, right?
Yeah, totally. Now, while audited, stage-by-stage data from 1926 doesn't exist in the exact same format, the historical record and the physical design of River Rouge show that roughly 75% of Ford's 81-hour chain was active production and transport.
That is a huge difference.
Only about 25% was waiting. The modern chain essentially took a highly efficient process and bolted nearly 9 months of waiting onto it.
It is so incredibly frustrating to think that material wasn't spending months being meticulously built. It was just spending months resting in a parking lot or a warehouse.
Right. And you have to remember, these companies are run by highly intelligent managers.
Exactly. They didn't just accidentally misplace 9 months. They had to have deliberately created these massive, slow-moving stockpiles. So the question is why?
Well, to understand that behavior, we have to look at the underlying metrics driving those managers. Dr. Barnard calls this the illusion of local optimization.
The illusion of local optimization. Okay.
Yes. So the Tata business units all shared a shareholder. They belonged to the same corporate group, but they did not share an operational goal. Each link in the chain was measured on its own local profit, its local cost per unit, and its local utilization.
Oh, I see. So they were basically functioning as independent competitors, fighting with each other inside the same corporate fence.
Worse than fighting, they were actively undermining the overall system to save their own spreadsheets.
Give me an example of that.
Sure. So if you manage the iron mine and your performance review is based on local profit, you are strongly incentivized to sell your iron ore on the external open market if the price is higher than what your internal steel plant is willing to pay.
Oh, wow. So you just sell it to a stranger instead of your own company.
Right. And if you manage the steel plant and you are measured on lowering your raw material costs, you're incentivized to buy ore from an external supplier if they offer a discount.
Right, because you have to hit your local KPI.
Exactly. And if you are the plant manager measured on machine utilization and unit cost, you run massive, huge batches of steel to keep your machines running constantly. Stopping to wait for actual demand makes your local numbers look bad.
Even if the next link in the chain has absolutely no need for that steel yet. You build a mountain of finished goods because producing it keeps your specific plant looking efficient to corporate.
You're optimizing your local link at the direct expense of the chain's overall flow. And this isn't just a behavioral quirk. There is a rigid mathematical formula behind this delay, rooted in queuing theory.
Okay, lay the math on me.
The formula is total time equals work time divided by 1 minus utilization.
Okay, here's where it gets really interesting.
Yeah.
Let's bring this down to earth for you listening, because this formula explains so much about our daily professional lives.
It really does.
Think about your own email inbox or a straightforward one-day task you were assigned at the office. If you are sitting there doing absolutely nothing, 0% utilization, and a one-day task lands on your desk, it takes you exactly 1 day to finish it.
That's the baseline, right? Now apply the formula to a normal workload.
Right. So if you are 50% utilized, meaning half your day is booked with meetings or other work, the math says that 1 day task takes 2 days to get done, 1 day of it waiting for your attention, and 1 day of actual doing.
Yeah.
But if you are 90% utilized, the formula dictates it takes 10 days, 9 days of waiting in your queue and 1 day of doing.
And here's the kicker. If your company is trying to be maximally efficient and has you running at 99% utilization, that 1 day task takes 100 days.
That is insane.
Yeah.
It spends 99 days waiting for you to have a free minute and 1 day of actual work.
It is a viciously nonlinear curve. Almost all the systemic damage is done in those last few percentage points of busyness.
Right. So when you push a system from 90% to 99% utilization, you aren't just getting 9% more output.
No, you are exponentially increasing the waiting time for every task in the system.
Yeah.
And the reason this happens is variability.
Because things never go exactly to plan.
Right. In the real world, tasks don't take exactly the same amount of time, and they don't arrive at perfectly spaced intervals. So if you are running at 99% capacity and a task takes slightly longer than expected, a backlog forms.
Yeah.
And because you have no spare capacity, that backlog never clears.
It operates exactly like a major highway. When a highway is at 50% capacity, everyone easily drives the speed limit.
Sure.
But when it reaches 99% capacity, it only takes one driver tapping their brakes to create a shockwave that turns the entire highway into a parking lot.
That is the perfect visualization when you measure every manager on utilization, demanding they keep their machines and their people busy 100% of the time. You are mathematically guaranteeing a parking lot.
Wow.
The 270-day delay wasn't incompetence. It was the completely rational output of a system designed to maximize utilization.
And Dr. Barnard highlights a specific, incredibly destructive human behavior that arises from this, which he calls the CFO effect.
Oh, yeah, this part is wild.
It really shows how deep the misalignment goes, specifically around financial reporting.
Right, so he observed this phenomenon at one of the largest mining companies in the world. As the fiscal year-end approaches, the CFO needs to show investors the highest possible return on investment.
Which means they need cash, right?
Exactly. And the fastest way to artificially inflate that metric on a balance sheet is to hold very low inventory. So the CFO sends out a directive instructing every link in the chain to shed inventory as quickly as possible.
Just clear the books so the company looks lean and mean for the quarterly call.
The problem is how the managers achieve this. They take their stockpiles and sell them off at massive discounts to external traders just to get them off the books.
Yeah.
But business doesn't start just because the fiscal year ended. Right after the new reporting period begins, the company realizes they don't have enough material left to fulfill their actual ongoing contract.
So they just held a fire sale.
Yeah.
So they have to replenish immediately.
Yes. And to do that, they end up buying their own product back from those exact same external traders, but now they're paying massive premiums.
That is unbelievable.
From a system level, it is a catastrophic destruction of profit margins. It creates massive operational chaos. But for the local manager trying to survive a financial KPI dictated by the CFO, it is entirely rational behavior.
It just proves that measurement, not ownership, dictates behavior. And this leads to a highly counterintuitive truth in modern business.
Yeah.
Spare capacity isn't waste. It is the literal price of flow.
Yes, absolutely.
If you want a 3-day supply chain instead of a 270-day supply chain, you must allow some resources to not be 100% utilized.
You have to protect your flow from the queuing theory curve.
So if local measurements are causing these massive delays, regardless of who owns the company, this completely blows up the logic behind most corporate mergers and acquisitions.
Oh, 100%.
I mean, imagine being a manager at a newly acquired supplier. Your corporate logo on the building just changed, but your bonus structure didn't.
This is exactly why so many M&A deals fail to deliver their promised value. Companies will pay massive control premiums, billions of dollars to buy a supplier or a distributor.
Thinking it will fix everything.
Right. The logic is always that they need to control the value chain to force alignment and reduce costs. But on day one, after the merger, they keep the exact same local metrics in place. They still measure the newly acquired business on its local profit, its local cost center, and its local utilization.
So what does that mean for mergers and acquisitions? They spent billions to buy the physical assets, but they preserved the exact same misalignment that existed when the companies were separate.
Exactly. They basically just bought the legal right to own the traffic jam.
Wow. If you measure an acquired business exactly as you did when it was an independent stranger, it will continue to behave exactly like a stranger.
Which brings us to an incredibly important point, and it touches on one of the loudest debates happening in society right now.
The public versus private debate.
Exactly. And just to be crystal clear to you listening, we are not taking a political side here. We are strictly looking at the mechanics of operational flow as analyzed in the white paper. But there is a massive ongoing argument today about whether critical industries, things like energy grids, housing development, or medicine, should be owned by the government or the private sector to ensure low costs, fast delivery, and high quality.
Right, and it's a debate that generates a lot of ideological heat.
No, tons of it.
But if we connect this to the bigger picture, when we look at the mechanics of flow, the Ford and Tata comparison proves a vital point. The identity of the owner is completely irrelevant to the flow of the system, which is hard for people to accept because people tend to assume that government ownership inherently means one set of outcomes and private ownership inherently means another.
But look at the operational physics. If you transfer a private supply chain into public hands, or, if you privatize a public service, but you keep measuring the local managers on budget absorption, local cost cutting, and maintaining maximum local utilization, the system will behave exactly the same way.
Because the math is the same.
Exactly. Tata was an entirely private enterprise, and its measurement system generated 270 days of waiting. If a government-owned supply chain measures its success by ensuring every department is fully utilized and minimizing individual department budgets, the material will still wait in queues. The citizens will still wait.
Because affordability and speed aren't magical properties granted by who holds the deed to the building. They are outcomes of system flow.
Precisely. Prices fall and services accelerate when a chain meets demand, moves quickly, and gets things right the first time. The mathematical rules of queuing theory do not care if your paycheck comes from a corporate account or a government treasury.
Right. Ownership only tells you who legally controls the assets. Measurements dictate how those assets will actually be used in reality.
That's the golden rule here.
So, if common ownership is an illusion of control, then someone out there must be doing the exact opposite. I mean, someone must be achieving massive flow without actually owning the underlying assets.
And they are. Zara, the fast fashion giant, is the ultimate counterexample provided in the white paper.
Zara, like the clothing store.
Yeah, Zara is frequently praised for being vertically integrated, but in reality, they own very little of their manufacturing base. They rely on a network of over 8,200 external independent factories.
Over 8,000.
Yep. Yet Zara is famous for its astonishing flow. According to the classic Harvard Business School case study cited by Dr. Barnard, Zara can take a garment from a design concept to the racks of global stores in just 15 days.
Wait, 15 days across thousands of independent factories that they don't even have legal control over? How does a 15-day cycle actually function if you can't fire the factory manager for non-compliance?
Zara achieves this because they hold the orchestrating link, the design, the branding, and the crucial demand signal from the stores. They use that orchestrating power to align all those independent third-party factories around a single, unified goal, speed of response to the market.
Okay, so they align everyone around speed.
Right. To maintain that 15-day flow, Zara does things that would give a traditional utilization-focused manager a literal heart attack. They deliberately build and maintain extra manufacturing capacity. They produce in very small batches. They will even dispatch half-empty delivery trucks if it means getting the right product to a store on time.
Wow. A traditional logistics manager, measured on cost per mile, would look at a half-empty truck and call it an unacceptable inefficiency.
Yeah, they lose their minds.
No.
And that traditional manager would ruin the 15-day flow to save a few dollars on fuel.
Right.
Zara happily pays for local inefficiencies everywhere in the chain in order to win massively at the system level. They understand that alignment travels with the demand signal and the metrics, not with a legal deed of ownership.
Okay, so we've dismantled ownership as the magical fix. But, if maximize shareholder value or serve the public good are too vast and abstract to actually align a worker on a factory floor or clerk in a government office, what do we do?
It's a great question.
If I'm on a factory floor, I only know what's right in front of me. How do we translate that big abstract goal into something practical?
This is where Dr. Barnard introduces the expanded chain analogy. It is a highly practical framework designed to translate the system's abstract goal into daily, localized decisions.
Okay, how does that work?
Well, the system has one overall goal, but that goal must be translated into one specific, derived goal for each part of the chain based on what the downstream customer actually needs.
He breaks this down into a 5-step sequence in the paper, right? Let's walk through how this works in practice. What is step 1?
Step 1 asks the most fundamental question. Can we meet the volume of demand the system is placing on our link? If the answer is no, your single goal is more, and your constraint, the bottleneck, is the weakest link in your chain. Every other part of the system must subordinate to feeding that weakest link so you can simply meet demand.
That makes perfect sense. Because if you can't even produce enough volume to satisfy the market, cutting costs or tweaking features doesn't matter. You have to solve the capacity issue first.
Right. Once you are meeting demand and only then you move to step 2, you ask, are we fast enough to meet customer expectations? If the answer is no, your goal becomes faster. Notice that the constraint changes here. It is no longer the weakest link, it is the longest link.
Ah, I see the distinction. You might have plenty of capacity to handle the volume, say, at a local DMV or corporate approval board, but the routing process involves 15 different signatures. The system isn't weak, it's just convoluted and slow.
Exactly. You attack the longest lead time. Then, step 3 asks, are we reliable? Are we doing it right the first time? If the answer is no, the goal is better, and the constraint is the faultiest link, because the cost of rework destroys flow.
Right.
Step 4 asks, are we affordable enough to make a fair margin? If no, the goal is cheaper, and the constraint is the costliest link. It is absolutely vital to note that cutting costs comes fourth in this sequence, not first.
That is a massive paradigm shift.
Yeah.
So many companies facing trouble immediately start by slashing budgets uniformly across all departments. By doing that, they instantly ruin their ability to achieve the more faster and better goals.
Uniform budget cuts are the ultimate enemy of flow. You only optimize for cheaper once the product is flowing reliably.
Wow. Okay, what's step 5?
Finally, step 5, which is a question that can interrupt the sequence at any time. Has the system grown too complex? If yes, the goal is simpler, and the constraint is unnecessary links and linkages. Stripping away complexity makes the system stronger, faster, more reliable, and cheaper all at once.
Just to clarify this for you listening,
Yeah.
this framework means that not everyone in your company will have the exact same goal at the exact same time.
Right, they shouldn't.
One department might realize their internal constraint is quality, so their specific local goal is better. Another department might be perfectly reliable, but their process takes too long, so their goal is faster. But because they are all answering these 5 questions based on the overall system's demand, it all empirically aligns.
Exactly.
It completely removes toxic workplace politics. It's no longer about whose department shouts the loudest or gets the biggest budget. It's just a factual, mathematical look at what the system needs next.
It replaces political arguments with empirical focus. But, there is a danger here that must be managed.
Which is what?
Well, a localized department might try to game the system. They might try to get faster by quietly cutting corners on quality, or they might try to get cheaper by starving the spare capacity they actually need for flow.
Oh, okay.
To prevent this, you need a measurement that keeps these 5 goals honest across the board.
The white paper calls this ultimate measurement TRQ over OE. Let's break down that equation because it seems to be the linchpin of the whole system.
Yeah, TRQ over OE stands for throughput multiplied by reliability multiplied by quality, all divided by operating expense.
Okay.
Throughput is the raw amount of work completed. Reliability is the percentage of that work done on time. Quality is the percentage done right the first time. You multiply those 3 factors together and then divide by the total operating expense required to run the department.
Okay, I see why they are multiplied. It basically operates like a combination lock. Because they are percentages, if your quality drops to 0, multiplying by 0 means the entire top half of the equation becomes 0. Your productivity score tanks.
That is the mathematical elegance of the formula. You cannot mask a failure in quality by processing double the volume of throughput. If you try to lower your operating expense by firing your quality control team to save money, your quality percentage drops and your overall score plummets.
It mathematically neutralizes the ability to game the metrics.
And it is universally applicable. Dr. Barnard has successfully implemented this exact metric everywhere, from private tech giants like Cisco to public sector organizations like the Utah Governor's Office of Management and Budget.
Oh, that's wild. So it works for the public sector too.
Yeah, a government office uses it to measure the flow of civic services, while a tech company uses it to measure hardware deployment. But the math holds up perfectly. It forces every manager to optimize the flow of the whole rather than just optimizing their own little subsystem.
Bringing this all together, we can finally solve the 80-year mystery. Henry Ford didn't succeed just because he bought the iron mines and the forests. He succeeded because he ruthlessly optimized the flow of the entire system.
Yes, exactly. He didn't care if a specific machine was sitting idle. He only cared if the material was continuously moving toward the customer. Ownership is just a piece of paper that tells you who legally controls the assets. Measurements tell you how those assets will actually be used by the human beings managing them.
That is the core realization, and Dr. Barnard leaves readers with a self-diagnostic, which is a brilliant challenge to apply to your own work environment.
What are the questions we should be asking ourselves?
Ask yourself, what is your organization's 81 hours? In your specific business, what is the total elapsed time from the start of a process to the moment value was delivered to the customer?
Okay.
Once you know that number, map it out. How much of that time is actual work and how much of it is just waiting in a queue? And most importantly, look at what gets rewarded in your office culture. When being 100% utilized and keeping the work flowing come into conflict, and they always will, which one actually wins in practice? That is a deeply clarifying lens to look through on Monday morning. Are you being rewarded for being busy, or are you actually being rewarded for flow? Thank you for guiding us through the deep mechanics of this paper. It completely reshapes how you look at a traffic jam, whether it's on a highway or in a corporate supply chain.
It really is a masterclass in seeing the system rather than just the parts.
And thank you for joining us on this deep dive. Before you go, I want to leave you with one final provocative thought to mull over. We are rapidly moving into an era where artificial intelligence will be managing our workflows, our project schedules, and our global supply chains. What metrics are we going to program into the AI? If we give AI the traditional corporate goal to maximize the utilization of every human and machine resource, will the AI simply execute that queuing theory curve with ruthless perfection? Will it push us to 99% utilization and inadvertently create the most rigid, catastrophic 270-day traffic jams in human history? Or will we be wise enough to teach the AI to optimize for flow? Something to mull over until next time.